data scientist looks a bit more sexier than the other roles. I have this, or the media is depicting it like that. But I would believe that all roles are equally important. So you're a data analyst, you're a data scientist, you're a data engineer, you're a machine learning engineer, you're in the team.
This episode of Ken's Nearest Neighbors is brought to you by Z by HP. HP's high compute, workstation grade line of products and solutions. Today, I had the pleasure of interviewing Chanin Nantasenamat. He's a good friend of mine, and he's also an incredible teacher. He's probably best known for his educational videos about data science and coding on his YouTube channels, Data Professor, and his new channel, Coding Professor, which I've linked below in the description. Chanin's research interest is at the interface of biology, chemistry, and computer science, encompassing interdisciplinary areas such as bioinformatics, cheminformatics, chemogenomics, and proteochemometrics. Try saying that 5 times fast. These disciplines are instrumental for exploring the underlying origins of protein functions and its modulation, otherwise known as inhibition or activation. This type of research understanding holds great implications for the discovery of novel bioactive compounds with therapeutic activity. I think that just means new drugs. His research group also developed bioinformatic databases, softwares, and web servers for addressing perplexing biological problems. In this episode, we talk about how someone can break into the bioinformatics field. We also learn about Chanin's content creation journey and the incredible, wholesome story of how the Data Professor channel came to be. I hope you enjoy. Chanin, thank you so much for agreeing to come into the Ken's Nearest Neighbors podcast today. We have a pretty long history of being on YouTube together. We've made some pretty awesome content together, and I'm just excited to have you in to be able to tell your story, to talk about your experiences. And I am certain that everyone listening is going to get quite a bit out of you just hearing your background and talking about how you got interested in academia, bioinformatics, and also on YouTube. So again, I really appreciate you coming in.
Yeah, it's my big pleasure being here. And I was inspired from your content as well.
Well, it goes both ways. I've also been very inspired by your content. I think, we started creating YouTube content at around the same time, and I'd always see your videos and be like, wow, those are really good. I've got to up my game. And I think we just kind of ping-ponged off of each other, and we've both been able to grow in a very effective way. And hopefully we're both creating really valuable and useful content for everyone who's trying to break into this field or learn more about this field or learn more about the tools, which frankly, you explain the tools far better than I do, which I really enjoy watching. So if I'm ever like, oh, I want to learn something about Streamlit, I'll just go watch one of your videos. So the first thing I'd like to understand is how you first got interested in data and technology. What was that journey like for you?
Right. So let me bring you guys back to when I was in undergraduate studies in biology. So at the time, I was going up to my 4th year, and I was deciding what undergraduate research project that I should do. So I approached several professors, and then one of the professors, he had a data set about epidemiology study of the outbreak of malaria. And so he said that, okay, I have this data set. Take this Excel file, SPSS input file, and then analyze it. And then at the time I was like, wait, I want to do some experimental work. And so I passed on that offer. So I never really took that offer. And then I've found another advisor for my project. And then I was working on this project on copepods. It's like this small marine organism. And so I would go to the pond 3 times a day, morning, noon time, and also in the evening, like maybe 7 p.m. or 8 p.m. And then I would collect samples at various depths in the water, in the pond. And then I would count them in the lab, manually with a counter, put them on the Petri dish, put them in alcohol first to solubilize them, and then count them, and then looking at the diurnal migration, because these copepods, they migrate to the top level of the water during the nighttime. And then during the daytime, they kind of migrated downward into the depth of the pond. And so we were also collecting various other parameters like dissolved oxygen, COD, BOD. And so pretty much that was like my first exposure to data. And at the time I was using very basic statistical analysis, mostly using Excel and also SPSS. And so that was my first exposure. So I didn't really thought myself as a data scientist, or I was just like, like a normal biologist doing research. And actually the second time I was seriously thinking about doing data science, it was actually called data mining at the time. And so at the time I was doing my PhD, and there's this project on green fluorescent proteins. So they are proteins found in jellyfish, and they allow it to like fluoresce different colors. And so I had this crazy idea that, okay, there are several different types of fluorescent protein. Why don't I collect them and do some analysis on them? And so at the time I had no exposure to machine learning or data mining. And so I pretty much was fortunate to have met one professor at a conference. And so he recently graduated his PhD. And then he gave me this book on artificial neural network. And then after like some brief conversations, he provided some high level look at the field. And then pretty much afterward, I was Googling my way into doing data mining. And at the time it was Weka. So Weka is a graphical user interface software for doing data mining. So essentially it's a GUI. You just click, import data from CSV. And yeah, so that was my first exposure to doing data mining, building models using support vector machine, neural network, decision trees. Yeah.
I love that story. And it seems like you were learning these data skills to compound or make the current work you were doing in biology more effective, more useful. And before we get more into what that is, I'd be very interested in how you started getting interested in biology to begin with. And obviously the combination of biology and the machine learning techniques are what we now refer to as bioinformatics. But I'd love to hear about, again, the first time you got interested in biology, and then what it meant to you when you heard bioinformatics for the first time as well.
All right. Yeah. So that would bring, so let me bring you guys back to when I was in middle school. So I was in, I think it was in the 7th grade. Yeah, 7th grade. And so I was in, at a middle school in Los Angeles, California. And at the time there was this, there was this program where the science teacher informed us that we're going to have like recruitment for some students who are interested in competing in the science Olympiad. And so I was one of the student who was really interested in that. And so our school went to compete at the what do you call it? They call it the county district. And so all of the counties in the state of California are competing. And we got 6th place on the tower building. So essentially we would use like small wooden sticks, and then we would piece it together into like a tower. And then you would place the tower in between 2 tables. And then, so the tower would be in between 2 tables like that. And then they would tie like a string, like a string to a bucket of sand. And then they would put sand in the bucket. And so whichever tower could hold the most sand for the longest time would win. And so we got 6th place for that. No, actually we got 3rd place. We got bronze for that. And then there was another one. We built a rocket bottle, a water powered rocket bottle. And then we got 6th place for that as well. And so our team made it to the state finals. And then we were competing at the state level of California. If we made it, we would go to compete at the national level to represent California. But unfortunately, we lost. So we didn't take home any prize at the state finals. And I thought it was a really great experience then, because I get to meet all of the brightest students from all over California. The ambiance was kind of like, what do you call it? It's like adrenaline pumping. It's like you're like from a very small school. I was like from this small school in LA, and there were all these students who were maybe they're more prepared, they're more more knowledgeable, and so we were there. And so, but the thing we got out of that was like just like the love of science, like the ambiance, kind of really inspired me. And another inspiration for liking biology and science as a general would have to be Bill Nye. Yeah, so as a kid growing up, I would watch every day, like every afternoon I got back home. One of the first thing I would open up is Bill Nye, the Science Guy. And so I was really inspired from his TV show.
I love Bill Nye the Science Guy, I'll tell you. Oh my goodness, that's incredible. Well, I wonder if Bill Nye is a little bit before the time of a lot of the consumers of this podcast. I think that's I mean, I obviously watched Bill Nye growing up. I wonder when he retired. I mean, obviously it's so cool. He's like a global warming and world health and environmentalist advocate now, which it's cool to see that he's still involved with science and he's using his platform for a really good cause. So I absolutely love that. I wonder if he needs a data science team for some of his work.
Yeah, that would be great, right? Yeah.
Yeah. And so, one thing I always like to ask, obviously you're a professor, the data professor, coding professor, etc. How did you decide on going down the academic route? I mean, I guess that's one of the main courses for biology. If you're going into the sciences, you're either going to go to med school or you're going to go into research. But was there particular onus? Was there particular something that stood out about a PhD, especially you did your PhD not in the US, correct?
Right. I did my PhD in Thailand.
Awesome. I'd love to hear about your journey through that process.
Mm-hmm. Yeah. So let me bring you guys back to my fourth year. We were in the last semester. I was chatting with my friends, like, okay, what are you guys doing afterward? Like after graduation, some would go for med school, some would go for grad studies. Some would just say, okay, I hate biology, I quit, and to start their own business or work with their family business. And so for me, I was like, I really didn't know what I wanted to do at the time. And I had this imposter syndrome. It's like, okay, we spent 4 years studying and I felt like I know nothing. And so I wasn't really prepared to work. And so my route would be either to go to med school or to go for a grad study. And then there was one day I opened up the TV and then I saw this like documentary, like a science documentary show. And they showed this video of a mouse, and on the back is like an ear. It looks like an ear. And so they were actually doing grafting of this tissue onto the back of the mouse, and they were inducing it using like stem cells and what growth factors to induce cells to differentiate into ear-looking cells, and also graft it onto a scaffold that gives the shape of the ear. And so I was pretty inspired from that. And then I was like looking, okay, I wanted to do that. And then I was looking out for some PhD programs or master's programs that would allow such research. And another important factor was that I would like to have like to be able to study for free, right? Because I heard from somewhere that if you're doing grad study, well, they might have scholarship for you. And I did some shopping, like hopping over to different programs, talking to different potential advisors. And and another incident was I talked to one of my undergraduate professor, asking him for advice. And he asked me like, why do you want to pursue a PhD? And I was like, I want to change the world. It's, that this innocent thinking, like I want to change the world. I want to hopefully one day win the Nobel Prize. And then he kind of shattered the dream. He said like, do you know how hard it is to win the Nobel Prize? And yeah, he kind of discouraged me. And I didn't really listen to that. And I still thought that, okay, I would win the Nobel Prize one day. And so I proceeded to applying for the PhD program. and in the first year, I kind of felt stuck. Like experiments were not working, results are not really that great, and then I had to prepare this presentation, a poster presentation, to go to a conference. And that is when it kind of turned around the situation, because I met this newly graduated professor who would introduce me to artificial neural network, which would eventually spark my interest into data mining, and then which would lead me to do research using data mining. And eventually that field became data science. And yeah, so that kind of that was like the changing point in my transition into the data world more concretely, right?
This episode of Ken's Nearest Neighbors is brought to you by Z by HP. HP's high compute, workstation grade line of products and solutions. As datasets get larger, unraveling meaningful insights can become more time consuming and costly. Z is specifically made for high performance data science solutions, and I personally use the ZBook Studio and the Z4 workstation. I really love that Z workstations can come standard with Linux, and they can be configured with the data science software stack. With the software stack, you can get right to the work of doing data science on day one without the overhead of trying to completely reconfigure your new machine. There are a wide variety of hardware configurations, so you can easily find a Z solution that meets your specific needs. Now, back to our show.
I really like that story, and especially the fact that you got stuck somewhere. I think that's something that people don't realize how important it is that when you get stuck, you pivot. You don't, it's like you're digging this hole, right? You dig it down, and then once you get stuck, you just go a little bit in a different direction. You don't go all the way back up to the top and start again. And right. I resonate with that so much because honestly, that's the experience I had in my own career where I was saying something like, I want to be the greatest golfer ever, right? And I tried to play professionally. It became apparent that would not happen relatively quickly. But in order to improve my golf game, I started looking at the analytics. I started to want to understand that better. I got this new interest that was related to that profession. And then I was able to pivot a little bit and start exploring analytics more. But I had already had a little base in that. I had some understanding of that. It was related to my other work, my other playing golf. And that spun off this other completely new career that still has shades of my past life in it. But I was really able to, hopefully, the guys I work with would agree, excel in. And again, to me, that's like, hey, take what you've learned, pivot it a little bit, make it your own, and you'll be able to find something. You'll be able to make a career. You'll be able to find what you're really interested in if you keep searching in that way, rather than starting from scratch all the way over again.
Yeah, exactly. Right. But like at the time for me, it's like it wasn't apparent that data science or data mining would eventually become my passion. At the time, it kind of got me. It kind of solved the curiosity at the time. So the curiosity was just like, okay, what if we use data? What if we take this data or collect or compile data set and do some analysis? How would this property cause influence on another property? So it was like this naive thinking, like, okay, maybe we'll figure out something interesting. So at the time, it was more into like problem solving, and not really into the love of data, but it was like for the love of solving the problem. And recently, I think like a year ago, I saw this article. They said that all biologists or are computational biologists. And so actually in the field of biology, there's a debate, and there's a debate between experimentalists and the computational theorists. And so there's like a negative connotation, like for those who are doing experimental work, they're putting more effort. But for those who are computational, like biologists or theorists, they're having it easy. And so there's this conception, in the field. And sometimes there was one platform where I got like, I kind of felt bad because like one of the big name in the field, he's like an experimentalist, and he's pretty much like not appreciating computational work. And so that kind of discourages sometimes. But then like at the end of the day, I think we're here to generate data, and it's not like, okay, who's better than who, or even on LinkedIn or on YouTube, it's not like, okay, data science, data analyst, or data engineer. I mean, they're a team. They're like a data team. It's not like, okay, data science. Because the thing is, like, data scientist looks a bit more sexier than the other roles. I have this, or the media is depicting it like that. But I would believe that all roles are equally important. So you're a data analyst, you're a data scientist, you're a data engineer, you're a machine learning engineer. You're in the team. It's like a doctor, medical technologist, or you're healthcare professional. So I would like to believe that all of us are working as a team, kind of like a basketball or baseball. It's not like, okay, that a single position might be more into the spotlight, but at the end of the day, I mean, they work harmoniously as well. Yeah.
Yeah. Well, I think that analogy is really good, and it's something that, to me, the experimentalist versus the computational person, they're two sides of the same coin, right? The discovery or the simulation you're doing on the computation side, but to see if it holds true to the laws of nature or biology, physics, whatever it might be, you have to experiment to a certain extent. It's just like if we're looking at a business and we're talking about marketing, we're doing A/B tests of different ads, right? You're getting different data, you're getting different information, and you're learning and collecting data that can be analyzed by the other group. So in theory, these two groups should work symbiotically, and it should be a harmonious type thing. But I think in any type of knowledge profession, whether it's bioinformatics, data science, AI, machine learning, there's always going to be a little bit of ego attached to it, unfortunately. And sometimes that people find that if they're working so hard, their work must be more important than other people's work. And I mean, I certainly don't believe that. I think if we take YouTube for a proxy, like, I don't think the videos I'm making are any more important than your videos, or even like someone who's just making joke videos out there. Like, they're all equally important. It depends on who's watching it, right? Like, you can't quantify if like one video that someone made, it just like changed someone's life, right? I can't say that that's better or worse than another video that just helped with 100 different people improving their decision making. And so, sorry, that's something that I guess it hit a nerve. Is just that it bothers me when people are so self-important on their work. It's that, hey, like, we're putting this out there. Hopefully, it'll be useful, and hopefully, it'll change someone's life. Maybe we won't get you that Nobel Prize one day.
And also, like, as a content creator, I also love to watch other people's YouTube video as well. I mean, for one thing is to be inspired. Second is to be entertained. And a third thing is maybe to connect for possible collaborations. And like, I also like to watch like funny videos on YouTube, like Mr. Beast or That Was Epic. They're very awesome, and they kind of cleared my brain. Forrest Knight had a video. He called it, was it like a brain freeze? Yeah, he called it brain freeze. Like, like at the end of the hardworking day, your brain kind of got frozen. And so you can't really work afterward, like maybe do some extra coding. But I found that watching funny videos like Mr. Beast, like it kind of clear up the brain, unclogged it somehow. And then it kind of allowed me to, like code some more at night for YouTube. Yeah.
Yeah. Oh, it's funny. I mean, this is a little tangential, but I found that since I started making YouTube videos, I consume a lot more YouTube videos. And I think that if someone is taking YouTube or anything seriously, if they're not consuming the content of the medium they're creating on, something's wrong, right? They're probably not doing as good a job as they could be. And so, even if it's not for education, you're not trying to figure out how other people do these things better. Like if you're in data science and you want to be a data scientist, but you're not reading, I don't know, like towards data science, or you're not doing any research into data science in, during your day, or you're never coding in Python, right? You're just reading about it. You're probably going to struggle a little bit. So I think that there's a really neat lesson that's kind of hidden in there on that front. And so Something I would like to understand better while we're still in the topic of academia is that, from what I understand, professors usually have two responsibilities. So one is on the research side and one is on the teaching side. And I'd love to hear your first experience with teaching and how you felt about it, and if that's changed over time, as well as your experience with research, and maybe talk about some of the research that you've done or that you're working on.
Right. Yeah. So actually, there's other roles as well. Teaching and research are the two big roles of being a professor. A third role would also be to do some administrative work, like, for example, to plan educational programs, grad program, create new courses. So there's a lot of meetings after meetings for that. But my two passions are definitely teaching and research. I'm a bit on the weak side for administrative work. Although currently I'm working as the head of Center of Data Mining, and so there's a lot of admin work involved. And so I'm not really a great administrator, but I really love to teach and do research. Yeah.
Awesome.
In terms of teaching, yeah.
I was going to say it shows in your videos. So at least now, that it shows that you love to teach. Yeah.
Thank you. Yeah. So my first exposure to teaching was when I was recently graduated from PhD studies. So during undergrad, I didn't really have the opportunity to do a TA. At the time, there were no TA positions at my college. And so my first exposure to teaching actually was when I was a PhD student. I was helping out a professor to supervise a lab. And then I remember that I explained some concept to the students, and then the student I could saw the spark in their eyes, like, okay, they're like, wow, is that how the biological mechanism works? And so I felt really good. It's like you changed the understanding of a person, and it felt really great. And I think that was like one of the starting point of like my interest in wanting to teach more and more, because I wanted to make like difficult subjects or difficult topics to be a bit easier, or at least to clear up their understanding of that topic. And so, but then I met an obstacle when I entered my first teaching role. I was like taking part as a like an instructor as part of a research lab in microbiology, which I have zero knowledge in. And students would ask questions about like some microorganism. I would pretty much be blank. But the thing is, like as a professor, you have this image. It's like you have to know something, right? And so I was like, how should I solve the situation the students are asking? And I would disappoint them if I say I didn't know. And so my response was like, you know what? That's a great question. Why don't you go back and read some more, and we'll have a discussion about that. And so I got through that situation, and then the student went back and read, and then we discussed. And then based on what they're telling me, I was pretty much like piecing together different knowledge from different students, and then summarizing back to them, giving back what they have given me. And so apparently it looks like I knew something when I was explaining to them. Yeah, but actually I was like learning on the fly at the moment. Yeah.
Well, that's an incredible technique, kind of the Socratic method of answering a question with another question. And,
okay.
If you really want to sound smart in a meeting, just keep asking more questions. If you keep asking questions, you never have to answer any, right?
All right. Okay. I'll remember to use that more.
I really like that. Oh my goodness.
Cool.
And so on the research side, I'm also interested in what your focus was there. I probably won't understand it, to be perfectly honest, but I am still very interested in at least attempting to. Maybe I'll try your approach here with
All right, cool. Okay. So research, yeah, so during my undergrad, I did research, and as I mentioned earlier, I collected data on the migration patterns of copepods, the marine organism. And then during my PhD, I did some study, like engineering in the lab, some proteins that are having different colors of the jellyfish protein, green fluorescent protein. And I also did some chemical synthesis of polymers. But then, a long story short, what I did was take small molecules, like drugs like not like cocaine or drugs like aspirin or um, do I have a better example? Yeah, let's take aspirin for example. Okay, so an aspirin is like a small molecule, and it has this molecular structure. And so what we would do is we would translate this molecular structure, we would convert it into a numerical representation, and therefore it would become numbers. And then you would have a molecule represented by several molecular features. And so the features are like variables. And so if you have a big chemical library, then each row would be one molecule. And so if you have 1,000 or 1,000,000 molecule, then you would have a pretty much a big data. So it'll be like a tabular data set. The columns would be the features of the molecule, and the rows would be the molecule itself. And we would use this data to build a machine learning model. And so essentially after that, I mean, everything is following the machine learning model building process or the data science process as we know it.
Interesting. And so what after it's encoded in that way, what are you trying to find? Ones that are similar to it, or trying to find features that line up to certain outcomes? What is the kind of end goal on that front?
Right. So essentially what you have told me is the two end goals that we're looking into. For one, we want to know like the understanding of what features contributed to the properties we wanted to predict. For example, we want to predict the drug efficacy or the drug toxicity. We would try to find like what is the origin of the toxicity? What is the origin of the efficacy? And so the features will be telling us like, okay, which features are important. And so if you're using a linear regression, we would look into the regression coefficient. And so the coefficients having higher magnitude would be contributing more to the end outcome. And another one would be recently they have this library in Python called SHAP, the Shapley values. So this pretty much unravels the black box mechanism. And allow us to understand like how features are contributing to the end outcome. And so that's why I really love another one is the random forest algorithm, because it allows us to have a look at the feature importance from the Gini index value. Yeah. And another one would be, as you mentioned, also to select another similar drug. Like for example, if I developed a model to predict drugs for disease A, and I have disease B, which has no drug for it. But I found that drug molecule, I found that protein A and B, they look quite similar. And therefore, what works for A should theoretically work for B. And so therefore, I would say, okay, if I have molecules that could bind to A, I would pivot that to also try to test whether it also binds to B. And so the machine learning model would be able to say, okay, protein A, molecule one binds to A, and because A is similar to B, therefore I would take the molecule to bind to B. And so machine learning models could suggest some potential molecule that we would test experimentally. So it goes hand to hand. So it's data-driven experiment.
Nice. Well, that brings us full circle to what we were talking about before with how those two parts of the process are very symbiotic. Before we move off of the academia piece, I would like to better understand your experience. I mean, you grew up for the most part in the US, correct? And
Right.
starting your PhD and transitioning and moving to Thailand. What was that like? If I recall correctly, you have family in Thailand. Is that correct? So,
Yes. So
what was that experience like for you as well?
Yeah. So at the time, I moved back to Thailand when I was in finishing off my 10th grade. But before going back, I took the California High School Proficiency Examination, which was the equivalence of a high school diploma. And so the reason was like, for one thing, my brother, he was studying his undergrad, and he was with his roommates, and then and my dad had to go back to Thailand, and so I had no choice but to also return to Thailand. And at the time, I was 16-year-old, and I had this equivalence of a high school diploma. But then the thing was that the diploma equivalence was only applicable to the state of California. And so, yeah, my dad talked to some people at a college, and they were very nice to accept that. And so they said, okay, yeah, sure, we'll accept that for you. And so I got into college when I was 16. And at the time, I was like pretty much premature. I was like playing StarCraft, like every day after school playing StarCraft. And I had to grow up very fast, to enter first year of college. And so we were pretty much like, but then, like to my surprise, I mean, it wasn't really different. I thought that if I entered college, it's like, okay, this kid, I mean, how could I, communicate with, the older kids? And but actually only 2 years difference, and there were some points where we could connect. And so, but then the thing is, my knowledge in math or other topics, I've never taken a lot of courses like calculus. I had no exposure to calculus, and so I had to study harder than other people. Have to work harder, spend like double the time studying to get like the concepts, because I pretty much lost 2 years of high school. Yeah, but before going back to Thailand, I originally had a plan to apply to like a community college in Irvine, California. And then after 2 years of community college, maybe make a transition to UC Irvine to finish off the undergrad degree. But then the plan totally changed, because at the time my grandfather passed away. And so, yeah, my dad and myself, we moved back to Thailand. And so, yeah, so that was like a big change to my life. For one thing, it's like all of my friends are in the US, and I'm starting over in a new culture. So there's this big culture clash. And in Thailand, there's a lot of seniority. You have to pay respect to the elders, all that stuff. People who are older than you, you have to, pay respect to them. Even a year or 2 years older, in college. We have this term, we call them P. P means big brother. And in Thai, Nong for the younger, those who are younger than you. So it's like we're family. And so we pretty much like treat other people as like a family. So you would talk to a stranger, you would call them P, or you call them Nong. It's like, like, hey brother, hey little brother, kind of like that. And yeah, and another culture clash is that like in America, you would be able to like give your full opinion on stuff, but then in Thailand, the culture is not really that open. And so yeah, so there are some, like seniority thing. And so the younger, like for example, younger professors are a bit less reluctant to share, like the full opinion of the topic. So they'll only probably share the positive point, and the other are pretty much hidden.
I probably wouldn't do that well in Thailand, unfortunately. I have no problem sharing my opinion, so it's probably good that I'm in a more open culture these days. But no, that's fascinating. I think that the culture that we bring and our experiences shape so much of our worldview and even our work. And especially with data science and with COVID, we've seen the world becoming a lot bigger place because we're not forced to connect, but we also have the ability to connect with everyone. I mean, it's incredible. Yeah, I'm talking to you from Hawaii. You're talking to me from Thailand. We're doing a podcast together. We found time that worked, and I really like that element. And I think the future of data science work is going to be international, and understanding, for example, if I ever work with Thai clients or something like that, I have to understand those more, I guess, soft or closed cultural elements. And that's part of the job. That is part of communication. That is part of being a data scientist in some way. And realizing that and understanding that and adapting to that can make you very effective at your job or completely ineffective at your job. So I think that those little, I mean, it's definitely a very big thing, but not something that's always front of mind. But something that is absolutely very important and something I'm always interested in learning about as well. So I think that's all the questions I really had about academia and your work history and your experience there. I would like to talk about some of the fun stuff, how you got into content creation and those types of things. So you've told me the story offline, but I would love to hear again how you first got into making YouTube videos.
Okay, cool. All right. So so the story is like this. Like my daughter, she would be watching YouTube videos, like the ABCs or children's songs. Like there's this channel, Super Simple Songs, and then we would be like singing along. And then one day she was playfully telling me like, okay, why don't you create your own channel? And at the time I was like, okay, what would I talk about? Like, okay. And then over time, I was like searching for some topics in data science, and so like that was like maybe fast forward 2 months later, and then I came across some other YouTube channels. I think I saw your videos as well, and there was Chris Knight's video, and at the time I remember subscribing to Chris Knight's video from the How to Learn Data Science Smartly. And at the time, he was at about 30,000 or 25,000 subscriber, and now he's almost 400K already.
Yeah,
And yeah,
crazy growth.
And yeah, I was like, wait, you could do that on YouTube? You could talk. At first I was like, okay, I thought like YouTube is more like it's entertainment or like cat videos or like the Mr. Beast entertaining videos. And I'm like, wow, you could talk about data science and people actually want to watch data science. And so I'm like, okay, let's give it a shot. And so the first video was about like, I think it was strategies. No. It was how a biologist became a data scientist. And so that was like my first video. And another was like strategies for learning data science, was like maybe the eighth video, because at the time I was kind of camera shy. I was trying to find ways to like avoid talking on camera, and so I made this collection of videos on like data science quotes, inspirational quotes on data science, and yeah, and then afterwards I filmed more and more videos, and then yeah, there were some channels approaching me to maybe do some collaboration, and as like this, I think I'm pretty much introverted, and I'm kind of shy as well, and I kind of like had this like imposter syndrome. It's like, what can I offer to other people? And it's like, okay, wait, this channel wants to collaborate with me. Am I good enough to to talk to this person? I mean, I feel a lot of insecurities, and yeah. And at the time, you invited me for like a talk on LinkedIn, I think. Yeah, so you were like the first YouTuber that I talked to, and then eventually we collaborated on some videos.
Yeah, that's still one of my most consistent videos, the Hugo portfolio we did. I'll link it, of course, below. But yeah, I mean, I think it's really great that you're honest with the insecurities and the imposter syndrome. That's something that I think we all face. I know I face it. I might hide it a little bit more, but I also think that that's something that the more reps we get in, the more collaborations we do, the more content you put out there, the less you feel, because you can look back on that portfolio of work and say, hey, I think I'm almost at 200 videos now. It's like, wow, I've done all that. I mean, if it was really bad stuff, then nobody would have watched any of it. And
Right.
I think that's just such a powerful thing. I also love that the inspiration for getting into YouTube, just the little kind of whispering in your ear of your daughter, and I'm starting to see that now. I have two nieces, like sort of nieces. It's my cousin's kids, but I'm an only child, so Asian family, we just call them all nieces, right? But I'm so far away from them now. They're on the East Coast, and they completely know me through YouTube videos, right? Oh, it's my uncle.
Uncle
And
Ken.
yeah, it's crazy to think about that. I'm in their life exclusively through this. I mean, you can make calls, you can do whatever, but they recognize me, they know who I am. And I mean, that makes me really happy, is that not only is this a way to spread information, but as you mentioned before, it's an incredible way to connect with people within my family, but also like-minded people like yourself. We've met Tina, we've met Alex, the analyst. I've met a lot of people through this who I now consider friends. And uh, I'm just so grateful for that opportunity. We both made that decision to put something on the internet, and fast forward a year or two, at least for me, it's been one of the best things that's ever happened to me. So, I think it's just so cool that how far we've come in this domain.
Right.
Awesome. And so, I would ask. I'm trying to get more into understanding the best and the worst parts of things. And so, what do you think the best part of creating content on the internet is, or making YouTube videos? And also, what is the worst part?
Oh, okay. That's a tough question. Let's see. The best part. The best part is I'm getting to learn new topics. Number two, I get to meet awesome people like yourself and other YouTubers as well. Number three, I get to make a little impact, like make a little dent on the topic of data science. Because at the time, back in the day, prior to pre-YouTube era, for myself, it's like most of the work that we do, we publish it, and we'll be happy that someone cites our work. They include a mention of our paper in their own paper. But then it takes years, like to get one citation, at least 2 years or 1 year. To get cited beyond 10 papers, I mean, it's very difficult. Most papers that are published are never even read. Maybe they're read like a couple of times, but then we spent several months or years into making that research. But then I felt like, okay, wait, we're spending a couple of years making that, but then only a few people are reading it and using it. So it really doesn't really impact other people or other life. But then like, okay, I make a video and maybe I spent like 5 hours on it, so that's like
Thousands of people watch it.
0.001%. And a couple thousand people watch it versus spending a year on the paper, maybe impacting or maybe not impacting. Maybe they just downloaded the paper and never read it, 5 people. So I would believe that, making contents on YouTube would impact more people. And I've also discovered that there have been a lot of people who I would otherwise never have talked to, like for example yourself, or Shannon from NVIDIA, or other potential collaborators, or like conference organizers. They would be approaching me like, okay, would you be interested in giving a talk at this particular conference? And so I would believe that the best part of making contents on YouTube is I say that, for one, you feel good. You feel good that you're impacting the world. You're providing useful, I hope to be useful, educational content to the world that other people could use. And another great thing is that whenever I have like an incoming student to the lab, I could tell them, okay, please, can you watch this playlist? Can you watch this playlist? 1, 2, 3, and then we'll come and talk. And so that pretty much saved a lot of time, like having to repeat the same content over and over again. And because the video was structured and aims to cover several of the topics at the time, but then if you're maybe doing it like spontaneously, you might leave out some important topics. So I say that, like giving a playlist to new students is a great way for them to be acquainted to the topic, and then we would have further discussion. So I think that's the best part of it. Oh yeah, and one more is, like this possibility, like just a small pinch of possibility that kind of warms the heart, that in the future, what if this YouTube thing could become a full-time job? That's like one, like a possibility. It's like hoping for the lottery to happen, like that kind of feeling. Yeah. So maybe one day, if we're lucky, we could do this full time. And I'm very
That's
passionate
awesome.
about this. Yeah.
I think it's more than, I think you got significantly better odds than the lottery, Chanin. I hate to, I know, I'm happy to tell you that. So, that makes me very happy as well. And I agree with you 100%. I think that all those things you mentioned, I feel the exact same thing. And that's one of the reasons why I encourage so many people, not necessarily to make YouTube videos, but to put yourself out there, because there have been people off of print mediums. I've read blogs and I've reached out to people. There have been people across a bunch of different things, posting on LinkedIn, posting on Twitter, that I've said, wow, that's really useful. It's fascinating. I want to get to know this person, or I have an opportunity for this person even. And I'm also just grateful to be part of this broader ecosystem. So I have really two more questions. So the first is a little bit more about bioinformatics and how you would recommend someone who's interested in that to get started. Obviously, you have some great playlists on your channel. That can also obviously be one of the routes that they can take to get familiar. But what does that landscape look like? What are the opportunities in that field? Just a little bit more about that. That's something I'm not too experienced with.
Yeah. So for bioinformatics to get started, as you mentioned, I have a couple of videos on the topic, and so
I'll link them.
playlists or 2 playlists, linked down below. Another one would be that another misconception is that bioinformatics is not really that difficult. Although it encompasses a lot of domain knowledge, if you're going deep into a topic, you'll probably have to read more. But then getting started, all you need is just high school biology. And so I'm pretty sure that everyone has heard of DNA or proteins. It's just kind of like an entity, like a human being. Human beings we can describe a human being by their blood pressure, their heartbeats, like their glucose level. A molecule could be described by their molecular weight, their solubility, and so the analogy is quite similar. So that's essentially all you really need to know to actually build the model. But then the difficult part then comes at the interpretation. If you want to make sense of, okay, which features would influence the property that we want to predict, you'll probably have to read a lot. So for sure, you have to collaborate. It's not a one-man team or one-person team. So if you're a bioinformatician, you built the model, you got some interesting features that might contribute to that property that you're predicting. It's always nice to have a collaborator who's a biologist, okay, and talk, okay, these are the features, what do you think about them? And then they could provide their domain expertise. And so I would believe that is teamwork. And so getting started, well, you could get started right today. Yeah.
Awesome. Well, I think something I really liked about what you said is that it's a combination of very specific biology knowledge. And so that subject area expertise with essentially the data science skill set. And in any data science role, that's what you're doing, is you're taking what you know from statistics and machine learning and coding, and you're applying it to a specific domain. In this case, that domain is biology, no different than my work, where I'm applying machine learning, data science to golf for the most part and some other sports. I really have to dig down and understand the nature of those sports. Fortunately for me, golf, basketball, baseball is less complex than biology is, but it's a really important part of that whole process in whatever type of data science you're doing. So, dust off that biology textbook and some of those machine learning textbooks, and I think people will be able to pick up and learn definitely from your channel. So the last thing I wanted to learn about is, what is your vision for the future of your channel? Where can people learn more about you? Is there anything you'd really like to highlight about your content, or about anything really? This part's your part of the conversation to talk about whatever moves you.
All right, awesome. Yeah. So the future of my channel, I say that maybe, I think I would pretty much make more tutorial videos as I learn more topics. So I would say that it's like a cycle of, for example, for one thing is I'll make videos on what I know. And number two, I'll probably make videos on what I would like to learn about. And so I would learn and make content at the same time. And another one would have to be I want to probably explore some topics of maybe expanding the contents that I'm making on YouTube to other platform. So I'm thinking a possibility of maybe expanding the content to Udemy, to Skillshare, hopefully maybe making some community tutorials for data camp or like the other data science company like 365 or data quest. I see that they have like this community section where anyone could contribute a tutorial or an article. And so yeah, so and I also hope to create maybe some learning platform aside from similar to Udemy, or yeah, to put the content in, and that would allow the learner to systematically learn and probably provide some inbuilt functionality for providing like quizzes for them. And maybe they'll earn a certificate after watching the playlist. And so I might maybe repurpose some of those video onto the other platform and add like quizzes and Q&A, and so they could reinforce their learning. And so make their learning experience on YouTube a bit more structured, um, similar to what they would in a typical classroom. Yeah.
Awesome. I love that. Well, let me know if I can help in any way. I'm excited about that future that you described. And again, this is so awesome. I love chatting with you. It was awesome to hear more of your story this time than I've heard in the past. So thank you again for coming in, Chanin. And I'm looking towards more collaboration and getting this video out there as well.
Awesome. Yeah. And thank you very much for having me on your show.
Of course.